equation 2. This has now formed a simultaneous equation. Therefore, we now do the elimination method. We now have A plus 2500k is equals to 350. This is equation 1. Equation 2. A plus 900k is equals to 190. This is our equation 1. We minus equation 2 from equation 1. A will now be eliminated. Then we'll be left with 2500 minus 900 will give us 1600k, which is equals to 350 plus 190 will give us minus 190 will give us 160. Therefore, the k constant is equals to 160 over 1600, which is equals to 1 over 10. Substituting for k in equation 1, that is A plus 900 times 1 over 11 is equals to 190. Therefore, A is equals to 190 minus 90, which is 100. Equation R. From the equation, R equals to A plus kv squared becomes R. Substituting the values of the constants, which is 100 plus 1 over 10 v squared. We are asked to get the velocity when R is equals to 302.5 Newton. That is, the resistance is 302.5 Newton. Then substitute the resistance, which is 302.5, which is equals to 100 plus 1 over 10 v squared. Then, since we are looking for v, we take v to the left hand side and the figures the right hand side. Then we have 302.5 minus 100. V squared will now become 10 times 202.5, which is 2025. Therefore, V will now remove the square root sign to go over to become the square root of 2025, which is 45. Therefore, V is equal to 45 km per hour. Question 7. The cost of feeding number of students during a certain period is partially constant and partly vary directly as the number of students. The cost of feeding 75 students during a certain period lay 875.00, and the cost of feeding 100 students during the same period of time is lay 100.00. Find the cost of feeding 220 students over the same period of time. Answer. Cost of feeding is partly constant and partly varies as the number of students. To represent this mathematically, anytime we hear of and in mathematics, it signifies addition. Then we see that C is equal to A plus Km, where C is the cost, A and K are constant, and N is the number of students. If N is 75 and C is equal to 875.00, therefore 875 is equal to A plus 75k. This is our equation 1. If N is equals to 100 and C is equals to 1000, therefore substituting the values, we now have 1000 is equals to A plus 100k. This is our equation 2. Solving equation 1 and 2, we have A plus 75k is equals to 875. A plus 100k is equals to 1000. This is our equation 2. Equation 1 minus equation 2 will now give us 0 minus 25k is equals to 125. Therefore, k is equals to 125 over 25, which will give us 5. Substituting in I, we have a plus 75 times 5, which is equals to 875. A plus 375 is equals to 875. Therefore, A, making A the subject of the formula, we now have 875, 300 plus 375 crossing the other side will become minus 375, which we now have 500. Therefore, C is equals to A plus KW, which is equals to, substituting the values we have. For A is equals to 500 plus 5M. The cost for feeding 220 students will now be equal to C is equals to 500 plus 5 times 220, which is equals to 500 plus 1,100, which is supposed to be 1,600. Question 8. The electric conductivity in a wire of circular cross-sectional area varies directly as the square of the radius and inversely as the length. One wire is twice as long as the other, but the radius of the cross-section of the shorter is 3/2 times that of the longer. Find the ratio of their conductivity. Solution. From the questions, we are told that the electric conductivity in a wire of cross-section varies directly as the square of the radius and inversely as the length. We can represent this mathematically after removing the inverse sign to become E is equals to K r squared over L, where K is the constant. The length of wire, the length is equals to first wire over 2L times second wire over L. Radius is equals to R and the 3R over 4L. E is equals to K r squared over 2R and or 9K r squared over 4L. Dividing equation 1 and 2, we have E of, that is conductivity of the first wire over conductivity of the second wire, is equals to K r squared over 2L all over N K r squared over 4L. Therefore, once there is division, when there is division, if you multiply what is in the denominator will come to the numerator, and what is at the numerator will become the numerator. Then we have K r squared times 4L all over 2L times 9K r squared, which is equals to, if we cancel out, we will now be left with 2 over 9. Therefore, the ratio is equals to 2:9. Question 9. Two quantities P and Q are connected by a linear relation of the form P equals to KQ plus C, where K and C are constant. If Q is equals to 60 and P equals to 10 and Q equals to 240 when P is equals to 100, find the equation connecting P and Q. B. Set a graph of the relation indicating where it crosses the two axes.